Let's see how to implement any Boolean function with multiplexer. Suppose f is function of three variables a, b and c, and the Boolean function is a bar b c bar. Now we have to implement this Boolean function using 8x1 multiplexer. So first we will find out the mean terms in this for this Boolean function, and to find the mean terms we will use k-map, three variable k-map. For this three variable k-map, a is MSB and B and C are the LSBs. And the mean terms are, for A bar, all the elements of first row are 1, and for BC bar, this column is, all the elements of this column is 1. So the mean terms are 0, 1, 2, 3 and 6. Now to implement this function, Boolean function, using 8x1 multiplexer, all the variables are connected at the select lines. S0 is selected as LSB and S2 is MSB. So A is connected to S2, B is connected to S1 and C is connected to S0, and the input lines are input line. We have 1, 1, 1, 1, 0, 0, 1, 0. So this is Boolean function A bar plus BC bar using 8x1 multiplexer. Now we will implement this this Boolean function using 4x1 multiplexer. For this function we have three variables, and the mean terms are 0, 1, 2, 3 and 6. We have already the mean terms of the function. Now here we have three variables, and we will use multiplexer, 4x1 multiplexer, in which we have just two select lines. So we can adjust two variables, any two variables at select lines, and one variable we have to adjust in input. Four cross one multiplexer, two select lines, and the four input lines. Now let's adjust B and C at select lines. So now we have to adjust A at input line. Now to find out I0 to I3, we will use one more table, that is called multiplexer table. In this multiplexer table, select lines are taken as columns and input variable input is taken as rows. At the input we have to adjust A. First row is A bar, second row is A, and at the select lines we have to adjust two variables B and C. So first column is B bar C bar, second column is B bar C, third column is BC bar, and the last column is BC. So now we will do the numbering of the boxes. First is 0, A bar B bar C bar is 0, then A bar B bar C is 1, A bar B C bar is 2, then A bar B C is 3, A B bar C bar is 4, A B bar C 5, A B C bar is 6, and A B C is 7. Now we will put the mean terms in this multiplexer table. So 1, 0, 1, 2, 3 and 6 are the mean terms. Remaining terms are 0. Now the first column will decide input I0, which is 1 into A bar plus 0 into A, that is A bar. Second column will decide I1, that is 1 into a bar plus 0 into a, that is a bar again. Third column will decide I2, that is 1 into a bar plus 1 into a, that is 1. And third column will decide I3, and that is a bar. So inputs are a bar, 1 and a bar. This will give the desired Boolean function. Now in this implementation we have adjusted the variables B, C at the select lines. Now let us see what will happen if we adjust different variables at the input lines, at the select lines. Same Boolean function, same mean terms. These are the mean terms in which A is MSB, and C is LSB. Now we will try to implement the same function using 4x1 multiplexer, and we will adjust AB variables AB at the select lines and C variable at the input line. Here we will use C. Now multiplexer table. We have to use select lines in columns and input line in row. So first row is C bar, second row is C, and select lines are A and B. So A bar, B bar, then A bar B, A B bar, and A B. Now we'll do the numbering of boxes. So A bar, B bar, C bar is 0. A bar, B bar, C is 1. A bar, B, C bar is 2. A bar, B, C is 3. Then A, B bar, C bar is 4. A, B bar, C is 5. A, B, C bar is 6. And A, B, C is 7. Now we'll put the mean terms. 0, 1, 2, 3 and 6 are the mean terms. Remaining terms are 0. Now again first column will decide I0. 1 into C bar plus 1 into C is 1. I1 is 1 again. I2 is 0 into C bar plus 0 into C is 0, and I3 is 1 into C bar plus 0 into C, that is C bar. So the inputs are 1, 1, 0 and C bar. This is how we can implement different Boolean functions using multiplexers.